I'm WAKIYA, a conservation scientist with the Nara National Research Institute for Cultural Properties. Today, I would like to give an introduction on the storage environment of objects in the museum, explaining the mechanisms of deterioration. First of all, why do objects deteriorate? This table lists the factors that cause the deterioration of cultural properties. Deterioration factors include temperature and humidity in the exhibition and storage environments, light and gas in the air, factors related to living things that grow in the museum environment, such as animals that eat cultural artifacts, and events that broadly divide into natural disasters, such as earthquakes and fires, as well as human actions such as theft and vandalism. Here, temperature and humidity, which are particularly important among environmental factors, will be explained. Now let us consider what environmental conditions are best for artifacts. This table shows the temperature and relative humidity levels in storage environments for cultural properties recommended by organizations such as IIC, ICOM, and ICROM. For temperature, about 20 degrees Celsius is recommended, except for the storage of color film. On the other hand, the relative humidity varies greatly depending on the material. Also, materials such as wood, paper, ivory, and paintings need to be stored at moderate levels of relative humidity, and they have recommended lower and upper limits. By contrast, only an upper limit for relative humidity is set for metals and photographic films, and, generally speaking, the lower the relative humidity, the better the environment. For each type of artifact in this table, as there is a wider range in which to control for the humidity compared to the temperature, you can see that it is necessary to pay attention to the humidity. Here, I explain why it is important to control the temperature, and especially the relative humidity, for cultural properties. Sites and artifacts are composed of various materials, such as wood, stone, and metal. All of these are collectively called porous materials, as there are many cavities, that is, pores or holes, inside these materials. Here is an electron micrograph of wood in cross-section. Many cavities are clearly visible. When the humidity changes in the environment where these cultural properties are displayed and stored, moisture absorbed from the air will adhere to and be released from the surfaces of these cavities, making the cavity walls swell and shrink. And these changes in the moisture building up within the artifacts causes deterioration. Now, how much change in volume occurs? This figure shows how the amount of water in wooden material changes through absorption and release of moisture in response to changes in the relative humidity of the environment in which the wood is placed. For example, suppose a storehouse has an environment that is easily ventilated with outside air and has a relative humidity that varies from 40% to 80% over the course of a day. In this case, the water content of wooden artifacts in storage will change from approximately 6% to 13%. Along with this, the wooden artifacts undergo a change in volume due to the change in water content. That is, as the water content increases, the volume expands, and conversely, as the water content decreases, the volume shrinks. As a result, the surface of a wooden artifact will be constantly subjected to the forces of expansion and contraction from the wood inside. This is a huge load for fragile wooden artifacts. In some cases, this repeated stress can result in cracks on the surface of the artifacts. Therefore, It can be said that a stable environment where the relative humidity does not change is desirable for exhibits and storage environments. Here, I will introduce examples of trouble for objects caused by improper control of relative humidity in the exhibition environment. The photo on the upper left is the frame of a well that is made of wooden boards, and this item is displayed in a museum entrance hall in an exposed state. The lower left is an enlarged photo of the wood. You can see cracks that formed on the surface of the board. Also, the photo on the right shows an acidic liquid that formed on an iron artifact stored in a highly humid environment. In the case of iron artifacts, if they are displayed and stored in a highly humid environment, the liquid acid solution forming in this manner will further corrode the artifact, leading to its destruction within the display case. Also, if the relative humidity is too high, mold may appear on the surface of cultural properties. The photo on the left shows the mycelium of a growth of mold. Even in the case of an archaeological site, the humidity of the environment is very important. In the photo on the right, you can see green moss, black mold, and white salt on the surface of excavated soil that has been left open for display. In principle, it is best to preserve an archaeological site in situ, but it is difficult to control the exhibition environment when left open because if the humidity is too high, mold will appear on the surface, and if the humidity is too low, water evaporates from the soil, leading to deposits of salt. In this way, relative humidity is a factor that greatly affects the deterioration of artifacts during exhibition and storage, so controlling humidity is extremely important. This figure shows the relationship between the level of relative humidity and the time required for mold colonies to form. The higher the humidity, the faster the growth rate of mold. And in an environment with 100% relative humidity, a mold colony can appear in just 2 days. As the relative humidity of the surrounding environment decreases, the time required for colony growth also increases. It takes 1,000 days, or about 3 years, for colonies to develop in an environment with a relative humidity of 65%, and no mold growth may be observed at a relative humidity of 60%. Therefore, it can be seen that the risk of mold can be avoided if the relative humidity is kept below 60%. In this manner, you can see how the temperature, and especially the relative humidity where artifacts are displayed and stored, are factors greatly affecting the deterioration of artifacts, so their control is extremely important. Now, let's think about the effects of temperature on artifacts. In Japan, the temperature of the exhibition and storage environment is generally set in the range from 20 to 25 degrees Celsius. This involves a little chemistry, but generally a chemical reaction proceeds faster when the temperature of an object is higher. Of course, the deterioration of artifacts also involves chemical reactions, so in order to hold back the progress of deterioration, it is best to store artifacts at as low a temperature as possible. However, if the temperature is too low, then for example, condensation will form when we take artifacts out of storage, and the operating cost of the air conditioning will also be high. So it is not the case that the lower the temperature, the better. For these reasons, in Japan we set the temperature to between 20 to 25 degrees Celsius. Next, I will explain humidity. Humidity has two definitions. One is relative humidity, which we use often. The other is called absolute humidity, which may not be very familiar to you. The definition of absolute humidity is the amount of water vapor contained in 1 kilogram of dry air, as expressed by the formula shown here. It can also be expressed as the amount of water vapor contained in 1 cubic meter of dry air. In any case, the definition of absolute humidity is a value that does not depend on temperature and is the absolute amount of water vapor contained in a certain weight of dry air or a certain volume of dry air. Next, I will explain relative humidity. As humidity is a much more vital element than temperature in the environment for safekeeping artifacts, you should have a good understanding of it. The definition of relative humidity is the ratio of the absolute humidity, the amount of water vapor currently contained in the air, to the amount of water vapor contained if the air is saturated, that is, full of vapor, at a certain temperature. The definition of the amount of water vapor, if the air is saturated, is the maximum amount of water vapor that can possibly be contained in 1 cubic meter of air at a certain temperature. The important point here is that as the temperature of the air decreases, the amount of water vapor, if the air is saturated, also decreases. The amount of water vapor, if the air is saturated, changes with temperature. So even if the absolute humidity is constant, the value of the relative humidity changes with temperature. The figure at the bottom of the slide shows the relationship between absolute humidity, the amount of water vapor if saturated vapor, and relative humidity. Here, the size of the container represents the amount of water vapor if the air is saturated, and the actual amount of water in it represents the absolute humidity. When the temperature is 30 degrees Celsius, the amount of water vapor if the air is saturated is high, and therefore the volume of the container is large. So, the absolute humidity currently contained is half the amount of water vapor if saturated vapor. That is, the relative humidity is 50%. When the temperature drops to 23.1 degrees Celsius, the amount of water vapor, if the air is saturated, also decreases, and the volume of the container also decreases. At this time, the absolute humidity has not changed, but since the ratio to the amount of water vapor if saturated vapor has changed, the relative humidity changes to 75%. As the temperature further decreases, the amount of water vapor, if the air is saturated, further decreases, and eventually reaches the same value as the absolute humidity. At this time, the relative humidity becomes 100%, and the temperature at this time is called the dew point. And when the temperature drops further, the water in the container can no longer stay in the container and overflows. This condition is condensation, and the amount of water that overflows is the amount of condensation. This is called a psychometric chart and shows the relationship between temperature, absolute humidity, relative humidity, and dew point. The horizontal axis shows the temperature. The vertical axis on the right shows the absolute humidity, and the curves, drawn many times, show the relative humidity. If you know two of these values for a given environment, we can obtain all the other values from this figure. As anyone who has experience measuring temperature and humidity knows, a thermohygrometer generally records temperature and relative humidity. For example, assume that the measurement results in a temperature of 25 degrees Celsius and a relative humidity of 50%. Then, you can see that this air is, in the state indicated by the arrow in the figure, where the value on the horizontal axis of 25 degrees Celsius and the curve for a relative humidity of 50% intersect. If you draw a straight line from this intersection to the vertical axis on the right, you can see that the absolute humidity of this air is 0.01 kilograms per kilogram. That is, 1 kilogram of dry air contains 10 grams of water vapor. Further, the dew point temperature for this air can be found by extending the line straight to the left and observing the temperature on the horizontal axis at the point where it intersects the curve for a relative humidity of 100%. In this case, it will be between about 13 and 14 degrees Celsius. In general, you can calculate absolute humidity and dew point temperature from a function that shows the relationship between these values. So why do we need two different types of definition of humidity when thinking about the preservation of cultural properties? That is, because the effect on artifacts is different for each type of humidity. In order to examine the stability of artifacts, that is, whether the water content of an artifact is stable, or whether it has absorbed or released moisture, it is necessary to evaluate the relative humidity in the environment. On the other hand, in order to determine whether outside air has entered the display case, it is necessary to consider absolute humidity. Let's consider this while looking at an example of actual measurement in the next slide. First, let me introduce a way of investigating the temperature and humidity environment within an exhibition room. The graph in this slide shows the temperature measured in summer in the exhibition case, the exhibition room, and outside. This museum has air conditioning only during the daytime when it is open, and no air conditioning is used from the evening to the next morning. As in Southeast Asian and South Asian countries, the temperature and absolute humidity in Japan are extremely high during summer. The graph shows the results for 10 days, and the temperature of the outside air drawn as the orange line shows the fluctuation of the daily cycle. On the other hand, for the exhibition room, shown by the green line, and the display case shown by the blue line, even when the air conditioning is stopped at night, there is almost no increase in the room temperature, so the temperature is almost constant. Therefore, it can be said that the temperature is stable. This slide shows the humidity recorded for the same period. The upper part shows the absolute humidity, and the lower part shows relative humidity. The absolute humidity levels show lower values in the exhibition room and the exhibition case compared to the absolute humidity of the outside air. This means that the humidity of the outside air leaks into the interior of the building to only a small extent, indicating that the building is highly airtight. Focusing on the absolute humidity in the exhibition room, it can be seen as repeatedly increasing and decreasing every day. During the daytime, air conditioning dehumidifies the exhibition room, so the absolute humidity is seen to decrease sharply. On the other hand, at night, the air conditioning is turned off and no dehumidification takes place. At the same time, the outside air gradually leaks in, so the absolute humidity gradually increases and approaches the outside air value. On the other hand, the absolute humidity of the display case has hardly changed. In other words, it can be seen that the case is extremely airtight and almost no moisture from the exhibition room has penetrated into the case. In this way, by evaluating absolute humidity, you can see how much air is moving between the outside air, the exhibition room, and the exhibition case. Next, let's consider the relative humidity. In the outside air, the absolute humidity in the above figure was almost constant, whereas the relative humidity shows daily variation. This is because the temperature is changing. Recall that relative humidity is temperature dependent. Looking at the relative humidity of the exhibition room, it shows fluctuations on a daily cycle in the same manner as the absolute humidity. In contrast to the outside air, the temperature here is almost constant, so the relative humidity changes due to changes in absolute humidity. Therefore, the changes in absolute and relative humidity are similar. If artifacts are displayed in the exhibition room without being put in a case, the water content of the artifacts will increase and decrease every day. Therefore, if it is a fragile object, such as wood, there is a risk that cracks will form due to the changes in volume caused by changes in the water content. On the other hand, as explained earlier, the case is highly airtight, so there is almost no change in the absolute humidity as well as the temperature. Therefore, the relative humidity is also very stable and shows a constant value. From this, it can be said that the artifacts displayed in the case can be exhibited in a safe environment, with almost no absorption and release of moisture. I hope you now understand why controlling the temperature and the relative humidity is extremely important. Here, I would like to introduce the equipment commonly used for monitoring the exhibition storage environment. The device on the left is a bimetal thermohygrometer. The volume of metal easily changes with changes in temperature. This property is used to measure the temperature. The sensitivity and response are generally poor. The device on the right is a sensor commonly used for temperature and humidity monitoring, which is the data logger type. A data logger is a device which can automatically record the measured values, and many can record data for several months. Data are periodically entered into a computer and analyzed. The types shown in this picture can communicate via Bluetooth, so you do not need to take the device out of the case to collect the data. This is very convenient for monitoring inside the exhibition case. As just seen in the previous examples of measurement, it is easier to trace the movement of air from changes in the absolute humidity by monitoring not only in the exhibition room or storage room, but also at multiple locations outdoors or in the space around the exhibition room. I will now show some examples of how to control temperature and especially relative humidity. However, please note that the methods introduced here are designed for conditions of the Japanese climate. First, the most common technique is to use mechanical equipment, such as air conditioning and dehumidifiers. Next, the use of a material agent to control humidity, in combination with mechanical equipment, is common in exhibition environments such as museums. Finally, the most classic method is to store the artifacts in a wooden storage box. This helps protect from changes in the surrounding environment, as the wooden box itself absorbs and releases moisture in response to changing levels of humidity, which helps to keep conditions inside the box constant. Next, I would like to introduce how to control temperature and humidity in the exhibition room. The weather conditions in Japan are hot and humid in summer and cold and dry in winter. In the exhibition and storage rooms, the temperature is lower in summer compared to the outside. So, if the outside air is taken in by ventilation, the relative humidity will be higher than the outside. In such an environment, problems such as acidic liquids forming on iron artifacts and mold on wooden objects will occur. Therefore, in many storage rooms, we operate dehumidifiers in the summer months to reduce the absolute humidity. Also, unlike storage rooms, people are constantly entering and leaving the exhibition room, so it is an environment where the outside air easily enters. In such an environment, it is preferable to use a highly airtight exhibition case in order to reduce the influence of outside air on the artifacts as much as possible. For exhibition cases, even with a highly airtight case, there is some ventilation with the surrounding air, causing changes in humidity. Therefore, a humidity control agent is placed inside the exhibition case to minimize the change in relative humidity in the display environment. Humidity control agents absorb moisture which enters the case, and on the other hand, when the air inside the case dries, they release moisture as the humidity inside the case decreases. This has the function of keeping the relative humidity of the interior space constant. Based on the type of material in the display case, the target relative humidity ranges from high to low, and it is possible to purchase a humidity control agent for the optimal relative humidity accordingly. In the display case seen in the photo on the right, humidity control agents are put in a number of places where visitors cannot see them, such as behind or inside the exhibition stand for the artifacts. Here, I have explained the general measures used in Japan as an example. But, naturally, the weather conditions may be completely different depending on the region. In humid environments like Japan, air conditioning and other equipment is often used to maintain a good exhibition environment. However, in areas such as Central or Western Asia, it may be that the absolute humidity in the environment is low. When storing metal artifacts and so forth in such an environment, air conditioning may not be necessary because of the low relative humidity. Rather, cooling the air to lower the temperature would raise the relative humidity, which can adversely affect metal objects. Don't assume the environment of your museum is bad just because you don't have air conditioning facilities. First, monitor the temperature and humidity of your museum's exhibition and storage areas, and then consider what measures are necessary. I hope this lecture will help you to understand how you can do that.